Welcome back. In the last video, we saw how to conduct correlation analysis, which tells us the strength of correlation between two variables as well as the direction of relationship between those two variables. For example, if we conduct correlation analysis between knowledge management and firm innovative performance, it would tell us whether these two variables are positively correlated or negatively correlated and what is the strength of that correlation. But sometimes that is not enough, as we want to know more. For example, in this case, we want to know how much impact knowledge management has on firm innovative performance. That is something that correlation analysis cannot tell us. For this type of analysis, we need a regression analysis in which we quantify the impact of one variable on another variable. For example, the data set we are using for this tutorial has been collected by a student whose theoretical model looked something like this, in which knowledge management comprises three subconstructs, and the knowledge management is hypothesized to have a positive impact on firm innovative performance as well as on innovative job performance, and the innovative job performance has been hypothesized to have a positive impact on firm innovative performance. If we want to see if these hypotheses are true, that is, knowledge management actually has an impact on firm innovative performance, for this we will need to conduct regression analysis. Regression analysis is of many types. The kind we are talking about in this video is linear regression. As the name suggests, it is a regression which assumes a linear relationship between independent and dependent variable. So what are the independent and dependent variables? Consider this example again. We think, or the theory tells us, or we have hypothesized that knowledge management has an impact on firm innovative performance. This is not the other way around. We do not think that firm innovative performance has an impact on knowledge management. We think that knowledge management has an impact on firm innovative performance. So the knowledge management is our independent variable, and firm innovative performance is our dependent variable. It is also called outcome variable. And this independent variable is also called predictor or predicting variable. Okay. So there are two types of variables, independent and dependent. Independent variable is the one which we think has an impact on the dependent variable, and dependent variable is that we think is being impacted by the independent variable. So depending on how many predictors or independent variables are there, linear regression can be of further two types: simple linear regression, in which there is only one predictor, and multiple linear regression, in which there can be more than one predictors. Another important thing to note about this type of regression is that both the independent and the dependent variables are quantitative in nature. Okay, so these are some important properties of linear regression. How the linear regression is actually a very vast topic and full books have been written about it, and we are not discussing what linear regression is in detail here. We just want to see some basics and then see how this can be conducted in SPSS. Okay, so now let's see how linear regression analysis is conducted in SPSS. So let's go to SPSS and go to analyze. There is an option regression and there is a sub option linear regression. We'll choose that. Let's reset it. Okay, let's go back to our model and have a look. We think firm innovative performance is our dependent variable and knowledge management is our independent variable. Let's go to SPSS and put firm performance in dependent box and knowledge management in independent box. Okay, and we'll just click OK. Okay, the first thing we look at is this model summary, and in this model summary we see this value, adjusted R squared. This value tells us how much variation in dependent variable is being explained by independent variable. Adjusted R squared in this case is 0.21, that is 21%, 21.2% to be precise, which means, which we can interpret in layman's term as follows. Knowledge management explains 21.2% variation in firm innovative performance or firm innovation performance, or conversely 21.2% variation in firm innovative performance is being explained by knowledge management. Okay, and then we move to the next table and see if this model is significant. We look at this value against regression significance value. This should be less than 0.05, which in this case it is much less than 0.05. It is actually 0.000, which means that this model is significant. So we can say with some confidence that this model, which says that 21.2% variation in dependent variable is being explained by independent variable, is actually a significant model. We then move to next section, which is coefficients, and we then have a look at significance value against knowledge management, which again in this case is less than 0.05, and then we have this beta score. Okay, these beta scores, with these beta scores we can calculate our regression equation. Okay, let's see. Let's copy this coefficients table from here and paste it here so that we can write a regression equation. This actually tells us that Y, or which is firm performance in our case, firm innovation performance or innovative performance, firm innovation performance is actually this constant 5.979 plus. this knowledge management beta score for knowledge management, which is 6.818 times knowledge management. So for every value of knowledge management, now we can calculate the firm innovative performance. This is our regression equation. Okay. However, while running regression analysis, we normally need to see some graphs as well. Okay, so let's go back to regression and run this again. Go to plots and then put this in X and this in Y. What are these? I'll tell you later. Okay, so now we have a plot here, which is actually a scatter plot of regression standardized residuals versus regression standardized predicted values. And this scatter plot should display no trend or relationship. Okay, so we can see that there is apparently no trend because these data points are scattered here and there and they form no pattern. So this is an assumption which must be met. Okay, so we conclude that knowledge management actually has an impact on firm innovative performance, and knowledge management explains 21.2% variation in firm innovative job performance, and it is a significant model. Okay, this is simple linear regression. We can also conduct multiple linear regression. For that we will have more than one independent variable. So for example, we can include job performance in independent variables and the rest of the analysis will be same. And in coefficients table we will then have these two beta scores for these two variables. Okay, and if we take a look at model summary, this now tells us that our adjusted R square is 0.32. These two variables combined explain 32.7% variation in dependent variable, which in this case is firm innovative performance. So the rest of the tables can be interpreted the same way. Okay, so this is our regression analysis.